Hi guys, this is the 4.3 notes on multiplying and dividing rational expressions. So the first section we did last one was graphing them, finding the vertical and horizontal asymptotes. Today we're going to do some operations with multiplying and dividing. Okay, so again, a rational function or a rational expression, I should say, is the quotient of two polynomials, right? The domain is all real numbers except for which the denominator is equal to 0. So remember, right, a denominator cannot equal 0, and it's, again, the ratio of two polynomials. Okay. So remembering, right, our denominator cannot equal 0. So before we found the vertical asymptotes, right, by setting the denominator equal to 0. Today, when multiplying and dividing, we're going to set that equal to 0 to figure out which numbers are not in our domain. Okay, so if you look on the right, we know our denominator cannot equal 0, so we set it equal to 0 and figure out what it cannot be. Right, so x squared minus 9 equals 0. You get x squared equals 9. So x cannot equal plus or minus 3. Right, and we're going to call those things excluded values. So you'll hear that again. What are the excluded values? Well, excluded values are things that do not go in the domain. Right, they make our denominator equal to 0. Right, so this goes more into it. So an excluded value is one that makes the denominator 0. It is excluded because you cannot divide by 0. And to simplify, so you're going to have to simplify each expression. So to simplify means to factor the numerator and denominator as much as possible to see what cancels out. So we want to cancel out any common factors between the numerator and denominator. So this says simplify. What is the simplified form of this rational expression? What is the domain? So the domain we show by all real numbers except for the excluded values. So I'll define those excluded values. All right, so let's factor this out. We get 2 plus x, 2 minus x from factoring x negative x squared. 4 minus x squared, right? And then we get x plus 5 and x minus 2. Well, to cancel out, right, we can cancel out 2 minus x and x minus 2 if we factor out a negative 1 from this expression here. So factor negative 1 out. So we're going to make the whole numerator negative. All right, and we're going to make this x minus 2. Actually, sorry. The first one stays the same, x plus 2, and then we factor out a negative to make this x minus 2, right, instead of 2 minus x. Right, and the reason we did that is so now we can factor out the common factors of x minus 2, and our final solution is negative x plus 2 over x plus 5. Right, that's how we simplify it. Then, right, we find our excluded values. Right, we bring this down. X squared plus 3x minus 10 equals 0. Right, we factor it out again. So we get x equals negative 5 and x equals 2. So our excluded values are these. So our domain, right, is all real numbers, which you'll see is this r with a dash to it, except x equals 2 and -5, right? Or you could just say all real numbers, x does not equal to -5. Right, so that's your domain, and that's because you found those excluded values. So I want you to try this expression on your own, right? So I want you to simplify by factoring both, okay? And then, so remember, first take out an x from this one. So make it x squared minus 2x minus 3. And then factor out this one right here, right? And then if there's any common binomials, cross them out and simplify them. And then you need to find the excluded values to find the domain, right? The domain should be all real numbers except those excluded values. All right, here's the solution. So when you factor, you can cancel out an x plus 1. So it factors out to x plus 1 over x times x minus 3. And your domain is all real numbers except 0, because you set that equal to 0, -1, and +3. Right, those are your excluded values, so it's all real numbers except those 3. All right, now we know how to simplify, and we know how to find excluded values. We're going to go into multiplying rational expressions. So again, what you're going to do is multiply and then simplify by crossing out any common factors. Okay, so we're going to multiply 2x over z times 3x squared over 4yz. So we get 6x cubed y over 4yz squared. Right? We can cancel out the y's, and then we can reduce 6 and 4. So we get 3x cubed over 4. Sorry, not 4. We reduce that to 2z squared. Right, so now we look at our denominators. Right, so to find the excluded values, right, 4yz squared equal to 0. Right, so y cannot equal 0 and z cannot equal 0. Okay, so domain equals all real numbers except y equals 0 and z equals 0. And there is our reduced form. Okay. All right. Now let's look at this next one. We have some quadratics in here. So what you first want to do is maybe factor, if you can, and then multiply the so combine the numerators and denominators. Right, meaning multiply them, right, and then simplify by crossing out. And then lastly, find excluded values. All right, so we get 5x and x plus 3 times, I'm going to factor out that this x squared, right, so that will be x, what, plus 3 x minus 2 over x plus 1 times x plus 1 times x times x plus 1 over 5 times x minus 2. Okay, so now instead of we can kind of just combine these so all the terms are in the numerators and all are in the denominators. And now what we can do is cancel out any common binomials. So x plus 3 cancels, one of the x plus 1s, and the x minus 2s cancel. All right, so And also the 5 cancels, right? 5 and 5. So all we're left over with is an x and another x and an x plus 1. So we get x squared over x plus 1, right? And then our excluded values, so x cannot equal, right? Our denominators were x plus 3 times x plus 1, x plus 1, x minus 2, and then there was a 5 as well. All right, so x cannot equal -3, -1, and 2, because all three of those would make our denominator equal to 0. All right, so your solution is x squared over x plus 1, and x cannot equal -3, -1, and 2. All right, so the domain would be all real numbers except x equals -3, -1, and 2. All right, so I'd like you to multiply these on your own and try them on your own. Remember, try and factor all you can. For the a, I'll help you factor it first, right? We get x plus 4 and x minus 4. And then times x plus 10, x minus 9, all over. Now, whenever you see a 9 minus x, let's factor out a negative and make it x plus 9. Or sorry, x minus 9. All right, so we want to make our x positive, okay? That will allow you to factor out, cross out an x minus 9. And then write x plus 10 and x plus 4. Okay, so don't forget about that negative when you cross out, though. So that's how you factor them. Cancel out any common binomials, cross them out, or any leading coefficients you can cross out, and then find your excluded values. All right, so here's your solutions. You're able to cross out a lot in the first one. You only have negative x minus 4 left over. And your excluded values are -10, -4, and 9. The next one, when you factor them out, your x plus 3 cancels one of them. And then the 4x and x squared, you can cancel out one of those x's, right? So you only have an x left up top and a 4 on bottom for that part. And then you can reduce the 3 over 96 because it's 6 times 4, which is 24, times 4, which is 96. So you can reduce that to 1 over 32. And then your excluded values are 0 from the 4x and then -3 from the x plus 3's. All right. The last one is dividing. So it essentially is the same as multiplication, except we take the reciprocal of the second rational expression and then multiply. First, take the reciprocal, meaning flip the numerator and denominator of the second rational expression, then multiply. All right, so x cubed plus 3x squared plus 3x plus 1 over 1 minus x squared times, and then flip these, right? So we get x squared plus 3x minus 4 over x squared plus 5x plus 4. Okay, and now we're going to have to factor them out. Okay, so let's look at these, right? How can we factor them? Well, the first one is actually a special case, right? This is x plus 1 times x squared plus 2x plus 1, right, which also factors to x plus 1 times x plus 1 times x plus 1. Okay, then that's over 1 minus x squared, so 1 plus x and 1 minus x. Oop. And then we multiply that, and then we factor out this, and it becomes x plus 4, x minus 1. All right. And what we can do is on this one, right, we know we can factor out a negative, right? So I'm going to change that now, and I'm going to factor out a negative and then make this x minus 1. Right, that 1 plus x, it doesn't matter the order, so those will cancel out regardless. And then we get x plus 4 over x plus 1. All right, and now if you want, before you start crossing out, you can kind of find the excluded values, right? X cannot equal, right, negative 1, 1, negative 4, and then another negative 1, right? So there's your excluded values. Now let's cancel out so we can reduce. So here we can cancel that out, cancel this out, cancel these and these, and what left over is x plus 1, right, over negative 1, so negative x plus 1 is left over. All right, so this is our solution, and those are our excluded values. This one was a little difficult because it was a pretty big, you kind of had to recognize this special case for factoring out that first one. But if you wanted to, you could use synthetic division, find one of the factors and reduce it to a quadratic, right? So one of the factors would obviously be negative 1, and you reduce it to a quadratic, x squared plus 2x plus 1, and you could factor that out and it looked the same. All right, so what I want you to do is try these ones on your own, right? First, flip the numerator and denominator, then factor. So flip numerator, denominator of second rational expression. Then factor everything. Then we want to cancel any terms we can, right, or cross out common factors. And then lastly, right, find excluded values. So I want you to pause this now, try these on your own, and I'll show you the solution. All right, so here's the solutions. You can factor out a 3x from 3x squared minus 18x, and an x minus 6 is left over. And then you can cross out an x, and then cross out a, you take out the negative 1, and you have x minus 6, so you can cross that out. And what's left over is negative 3 over x plus 9. And your excluded values are negative 9 from the x plus 9, 0 from the x, and 6 from the x minus 6 in your denominator. Next one, your solutions ends up being 2x once you cross out the common factors, and your excluded values are negative 5 from the x plus 5 and 6 from the x minus 6.